Hello students, welcome back to the next module of a chapter called electromagnetic induction. Now students, in the previous modules we have already learned the construction, the working and the various mathematical formulas which were related to a device called transformer. Now students, in this particular module we'll be simply learning MCQs which are based on the concept of transformer, right? So let us start with the first MCQ of our module. It says, in a step up transformer, the input voltage is 300 volt and the output voltage is 15 kilovolt. Then the ratio of number of turns in primary to that in secondary is. Options are option A 1:20, option B 1:30, option C 1:40 and last option is 1:50, right? Now let's analyze this. Now over here we are having step up transformer. That means output voltage will be greater than the input voltage, right? So over here we are provided with input voltage. So let's say value of EP, it is equal to 300 volts. And in this particular situation, the output voltage, that is voltage across secondary coil, it is 15 kilovolts. So therefore I can say value of ES, it is equal to 15 kilovolts. And this 15 kilovolts can be written as 15,000 volts when we are converting kilovolt to volt. Now what we are supposed to find? Over here we are supposed to find the ratio of number of turns in primary to that in secondary. That means over here we need to find NP upon NS, where NP is number of turns in primary coil of transformer and NS is the number of turns in the secondary coil of transformer, right? So let us start with the solution. Now students, in order to solve this MCQ, we'll be using equation of transformer, right? What is the basic equation of transformer? NP upon NS, it is equal to EP upon ES. Now students, see carefully. We know value of EP. What is value of EP? It is 300 volts. We also know value of ES. What is value of ES? It is 15,000 volts, right? So see value. We have value of EP, we have value of ES. So let us substitute these two values. So what will I get? I'll get NP upon NS, it is equal to 300 upon 15,000. From here we can cancel out zeros. So after cancelling out zeros, we'll be left with 3 upon 150, and this 3 upon 150, if we calculate, we'll get final answer as 1 upon 50. Right? So in this case, the ratio of number of turns, that is NP upon NS, it is equal to 1 by 50. Now see the options carefully. Which option is matching? Yes, option D is the correct answer in this particular situation. Right? Now let us move further. Let us start with the second MCQ of our module. It says a step down transformer works on 220 volts AC means. It is used to light a 100 watt 20 volt bulb. The main current is 0.5 ampere. What is the efficiency of transformer? And the options are option A 91%, option B 80%, option C 71% and last option is 51%. Right? Now let us analyze this. Now students, over here we are provided with step down transformer, right? And in this particular case of step down transformer, the voltage on the primary side is 220 volts, right? So let us write down the given data. So I can write over here VP, it is equal to 220 volts. Now this VP is connected on the primary side, right? Now it is used to light a 100 watt bulb. Now this bulb is always connected across the secondary coil of transformer, right? So this is nothing but power across the secondary coil. So I can say P suffix S, which is nothing but power across secondary coil, it is equal to 100 watts. And the voltage across the bulb is 20 volts. So I can say value of ES, it is equal to 20 volts. Now next statement, the main current. Now whenever I hear a statement called main current, it is nothing but the current in the primary coil. And thus I can say IP, it is equal to 0.5 ampere. And what we are supposed to find? Over here, we are supposed to find the efficiency of transformer, right? Now students, we already know formula for efficiency. So let us start with the solution, right? So let us start. Now, so students, efficiency neta is given by output power upon input power, right? And output power is given by VS into IS and input power is given by VP upon IP. Now see carefully VS. Do we know value of VS? Yes. We know value of VS, it is equal to 20 volts, right? Now see IS. Do we have value of IS? No, we don't have value of IS. But we can calculate the value of IS by using PS and VS, right? Now students, we know that power is given by voltage into current. So secondary power is given by PS, it is equal to VS into IS, right? Now from this equation, I can rearrange and I can get the value of IS. So value of IS, it is nothing but equal to PS upon VS, right? Now we know value of PS. What is value of PS? It is equal to 100 watts, right? What is value of VS? Value of VS is 20 watts. right? So it will become 100 upon 20, and this is nothing but equal to 5 amperes, right? So value of Is is 5 amperes. Now see Vp. Do we know value of Vp? Yes, value of Vp is 220 volts. And lastly, value of IPC. IP is nothing but equal to 0.5 ampere, right? So let us substitute these values. So what we'll get? We'll get neta, it is equal to, right? It will be equal to 20 into 5 upon 220 into 0.5, right? And on finding, or rather on calculating, we'll get final answer as 0.9090, and if I convert this into in terms of percentage, I'll get 90.90%, which is nearly equal to 91%. Now see the options carefully. Which option is matching? Yes, option A is the correct answer in this particular situation, right? So students, in this particular module, we have focused on MCQs which were based on the concept of transformer. That's it for this particular module. I'll see you in the next module. Till then, keep learning.